Welcome to the deep dive. So, for the last couple of years, AI progress felt like this just huge wave of hype, right? Amazing demos, viral chats, sometimes a bit of panic.
Definitely chaotic.
Yeah, total chaos. But if you actually look closely at the sources we pulled for today, the game seems to be changing. It feels like progress is, I don't know, settling down into patterns you can actually measure, act on, and, repeat.
That's a great way to put it.
Yeah.
It's like we finally have a field guide to what's really being shipped.
Exactly.
And our mission for you, the listener, is really to cut through that lingering noise and pull out the real shifts happening underneath. We're seeing about 5 major patterns emerge, I think.
Okay.
Yeah, first, how we're trying to actually score intelligence. Then, what real-world use looks like. Think health, policy. Third, the huge changes in developer workflows. Fourth, all the guardrails needed for trust. And finally, the sort of boring but essential truth about infrastructure, silicon and power, basically.
Right, the nuts and bolts. And we should probably start with that biggest, maybe most audacious goal. How do you even quantify intelligence? It feels like the community's pushing hard now to move beyond just gut feelings about AGI.
Yeah, from vibes to variance explained, as one source put it.
I love that phrase, variance explained. Okay, but how are they doing that? Is it just like some company's internal benchmark?
Well, no, and that's what's interesting. They're bringing in serious academic discipline. The sources talk about this new psychometric AGI score.
Psychometric, like from psychologists.
Exactly. It's grounded in established human cognitive theory, specifically Kellhorn-Carroll theory.
Okay.
So they didn't just make up a test. They're targeting 10 specific cognitive domains. Things like fluid reasoning, memory, processing speed, all based on this framework. And it gives you a score from 0 to 100.
Right. And what are the first scores telling us? Is it sobering, exciting?
Kind of both. Actually, it gives a pretty frank picture. Early results put GPT-4, which many of us use, at about 27.
27 out of 100.
Okay. But then GPT-5 jumps way up to 57.
Wow. Okay. That's a significant leap. But 57 still isn't 100. What does that gap mean practically?
It means it's showing real competence in some areas, like reasoning speed, but still has these, massive gaps. Common sense, applying knowledge across different situations, the stuff humans do easily. It's a big jump, yeah. But it also clearly shows how far there is still to go.
So we're measuring the software, but you need the hardware to actually make these breakthroughs happen and, crucially, make them believable, right? This verifiability thing isn't just about models, is it?
Exactly. It hits the whole stack right down to the metal.
Yeah.
You want science, not just stunts. You need results that reproducible, credible. Take Google's announcement about their quantum echoes algorithm.
Okay, quantum echoes running on their Willow chip. It sounds pretty futuristic. What's the actual achievement there?
Well, it's about moving quantum computing from, like, a lab curiosity to a real scientific tool. They demonstrated what they're calling a verifiable quantum advantage.
Verifiable.
Meaning they solved a complex physics problem, a real-world one, not just abstract math, and got a reported 13,000x speed up over the best classical supercomputers trying the same thing. And crucially, someone else could run it and get the same result.
Ah, okay. So not just a fluke.
Right. And the relevance for, actual applications, this starts to bring quantum into things like chemistry, materials science. It acts like a sort of molecular ruler, helping figure out complex structures way faster. Think drug discovery, new materials.
That makes sense. Better measurement, better tools. Which leads nicely into seeing where these more measurable, verifiable advances are actually making a difference. In the physical world, in clinics.
Yeah, AI is an extender of human expertise. That feels like the right frame now.
And some of the clinical wins are really striking. That story about the Iowa mom.
Oh, yeah, the tumor site viz tool. Really powerful example. FDA cleared. Takes a standard MRI.
Which can be tricky to read sometimes, right?
Exactly. And this tool turns it into a precise 3D map for the surgeon, specifically for lumpectomies. Helps them be incredibly precise, potentially avoiding a full mastectomy. And it does this fast, using NVIDIA GPUs.
It's giving the surgeon better information, more confidence, not replacing their skill, but enhancing it.
Precisely. And we're seeing this kind of utility spread.
Yeah.
Like AI pharmacometrics being used in Africa.
How so?
It's tailoring drug dosages, specifically for malaria and TB, to account for the huge genetic diversity there. Using machine learning on pharmacokinetic data and knowledge graphs. They can bridge these historical data gaps for underserved populations,
Yeah.
making treatment safer and more effective.
That's incredible. Just massive potential impact. But it also highlights a potential pitfall we saw mentioned, right? Even with great ideas, the plumbing can fail.
Ah, yes, the side note about dentistry. Huge surge in AI interest there since, like, 2019. Ideas everywhere. But the data pipelines lag way behind the promise. You can have the smartest algorithm, but if the data feeding it is messy, incomplete, siloed, the whole thing grinds to a halt. It's that boring infrastructure problem again.
Always comes back to the infrastructure. Okay, shifting scale a bit, geospatial, robotics. AI is also starting to understand and interact with the physical world more effectively.
Definitely. Look at Google Earth AI using Gemini's reasoning capabilities. You can ask it complex, policy-style questions in natural language.
Like what? Give me an example.
Like, show me neighborhoods near this industrial zone that are also in a floodplain and have a high concentration of schools. It connects the dots. Or it can flag environmental issues like harmful algae blooms or shrinking rivers from satellite data, helping route resources faster for climate resilience.
So translating complex data into actionable insight just by asking.
Exactly. And then you have the robots themselves. Unitree's H2 humanoid is showing, frankly, stunning motor control. Ballet, kickboxing. It's not just stunts, it signals real maturity in perception and locomotion. Suggests it might actually be ready for useful work, maybe warehouses or tricky environments.
It's getting coordinated.
Very. And even simpler stuff, like Amazon's Pilot for delivery glasses.
Smart glasses for delivery drivers.
Yeah. They fuse what the camera sees with map data to give phone-free route guidance. The idea is less distraction, less cognitive load for the drivers navigating complex routes.
Okay, so from complex surgery to delivering packages, the theme seems to be AI getting embedded into workflows.
That's the perfect segue. This idea of AI becoming workflow glue is maybe the biggest shift for developers and enterprises right now. It's not just the chatbot you talk to anymore.
Right. So back to life sciences, you mentioned traceability being key. How does that play out?
Well, look at Anthropic's Claude for Life Sciences. It's not just a research assistant. It has specific connectors built in for essential lab tools, Benchling for lab notebooks, PubMed for research papers, Wiley for journals.
So it talks to the tools they already use.
Yes, and critically, it has agent skills. This lets expert teams basically package up their standard operating procedures, say, the exact steps for quality checking single-cell RNA sequencing data into a reusable, auditable AI tool.
Auditable is the key word there, I guess, for compliance.
Absolutely. It speeds up the science massively, but with a clear paper trail. You know exactly what the AI did, step by step.
And that kind of structured, traceable process is hitting software development, too.
Oh, big time. Claude code on the web is being described as a parallel cockpit for coding.
Parallel cockpit, meaning?
It connects to your GitHub repo, can spin up multiple isolated sandboxes to test code changes simultaneously, and then ideally returns a clean, verified pull request ready for review.
Okay, doing lots of checks at once.
Right. And you can even nudge these complex builds or tests along from your phone, kicking off a big job while you're, I don't know, grabbing coffee.
That efficiency angle is huge. Which brings us to cost. Processing all this data, especially documents, can get expensive fast, right? Token costs.
Exactly. And if AI is going to scale across the enterprise, you have to tackle that. This is where clever engineering makes a massive economic difference, like DeepSeek OCR.
Okay, OCR is optical character recognition. How is this different?
Instead of treating a document page as, say, thousands of text tokens, which cost money, it treats the page as a compact visual map. It compresses the whole page down into maybe 100 vision tokens.
Fewer tokens means cheaper processing, but is it accurate?
That's the breakthrough. It delivers something like 9x or 10x compression, but keeps really high accuracy, 96, 97%.
So what does that mean for, say, a company looking at its budget?
It means analyzing that huge archive of legal contracts or decades of research papers suddenly goes from being perhaps prohibitively expensive to actually feasible. It unlocks long context applications by slashing the cost. That's a huge deal. Okay, so the tools are getting smarter, more efficient, more embedded, but that only works if people trust them. And trust is fragile.
Extremely fragile. And the industry is definitely moving towards building in trust by design. But yeah, we keep seeing these wake-up calls. Privacy failures happen.
Oh, like the Grok chat's exposed incident.
Yeah.
That was bad.
Really bad. A simple share button ended up creating public URLs for private chats, indexed by search engines, health info, passwords, just out there.
The lesson seems so basic in hindsight. A share link for AI chat is effectively a publish button. You have to treat it that way.
Absolutely. And sometimes the risk isn't a bug, it's the default setting. Stanford HAI pointed out many major chatbots use your conversations for model training by default. You have to dig around to opt out.
Which most people probably don't do. Exactly. The recommendation is clear. Flip it. Make training opt-in. Affirmative consent. Plus, shorter data retention, better filtering for personal info by default.
We are seeing some positive moves in UI design, though, right? Giving users more direct control, like OpenAI's ChatGPT Atlas.
Yeah, Atlas is interesting. It's framed as an agentic browser, built around user approval.
Meaning?
Explicit toggles for agent actions, granular controls over accessing private memories or data, and built-in guardrails like it apparently can't access your local files. It pauses and asks for confirmation before touching financial sites, and it respects website instructions not to be crawled. More transparency, more control.
And this push for integration, making AI less of a separate thing you copy-paste into, that seems key too. Like OpenAI buying Sky to integrate ChatGPT deeper into macOS apps.
We're reducing that friction. Same idea behind GM putting Gemini-powered assistance in cars next year, making it a natural part of the driving experience ahead of their bigger plans for hands-off highway driving later.
But even with better UI and integration, there are lines AI shouldn't cross, right? Especially when it comes to judgment, ethics.
Absolutely. And we're seeing figures in authority draw those lines quite firmly. Sir Geoffrey Vos, the UK Master of the Rolls.
Head of civil justice, basically.
Right. He warned courts should balk his word at letting AI decide legal cases, even if AI could potentially do it way faster.
Why? Just efficiency isn't the only goal.
His point was that human judgment, empathy, understanding context, those are irreplaceable in law. AI can assist organize evidence, draft summaries, but the final decision needs a human.
That feels right. And we saw a similar warning about AI in mental health.
Yeah, a Brown University study raised serious alarms about some mental health chatbots flouting ethics. Things like faking empathy, giving potentially unsafe advice in crisis situations, not being clear about limitations.
So the call there is for?
Standards, clear disclosure, probably human oversight. Treat them as informational tools, maybe, but absolutely not as replacements for actual care. Big difference.
Okay, so we have models getting scores, tools getting embedded, and crucial ethical lines being drawn. But underlying all of it, there's the hardware, the infrastructure, the boring truth, as you called it.
Yeah. And it really is becoming the defining factor. You can have the best ideas, the smartest algorithms, but none of it scales without massive infrastructure.
The numbers are just wild. That McKinsey estimates $6.7 trillion needed for AI data centers by 2030.
Trillion, yeah. And the real choke point increasingly is power. Building the centers is one thing. Powering them reliably and efficiently is another challenge entirely.
So it's not just about having the capital to build, it's about energy strategy.
Exactly. Capital discipline, the sources call it. Who masters things like advanced liquid cooling? Who gets smart about scheduling workloads based on grid conditions? Who develops reliable on-site power generation? That's becoming the competitive edge.
It's engineering, but at a massive infrastructural scale.
Totally. And you see companies making huge long-term bets based on this. Anthropic planning capacity for up to 1 million TPUs by 2026.
A million. TPUs are Google's AI chips, right?
Right. And powering 1 million of those, that takes over a gigawatt of electricity. A gigawatt.
Wow. That's like a small city's worth of power.
Easily. And that's not just for training models faster initially. It's about having the headroom for safety research, for running these long context models for big enterprise clients consistently, day in, day out. Compute planning is the new supply chain management.
It even reframes things like layoffs, doesn't it? Meta cutting 600 roles.
The analysis suggests that was an execution bet. Consolidating strategy, making sure every single precious GPU they have is focused on delivering the next big visible capability jump, guarding the compute.
So the real winners might be the companies best at managing energy and building infrastructure, not just the ones with the cleverest prompts.
In the long run. It's looking increasingly likely. The engineers are basically power grid managers now, too.
Okay, so let's step back from this deep dive. If there's one central theme pulling all these threads together, what is it?
I think it's this intense focus on building trust through design, measurement, and clarity. Everything practical we talked about, from that surgical tool to the agentic browser, is being built with accountability and human control in mind. Or at least that's the stated goal.
Right. It's AI needing to earn its keep by being reliable, explainable, useful.
Exactly. It stops being just a cool demo and
Right.
starts actually carrying some of the expert load, reducing friction in science or coding or healthcare.
Yeah.
That seems to be the definition of practical AI progress right now.
Which brings us, maybe slightly ironically, back to measurement. We started wanting that hard number, GPT-5 hitting 57. We end up talking about all the crucial things that can't easily be scored. So, here's a final thought for you, the listener, to chew on. We now have this psychometric AGI score, capable of putting a number, like 57, on a model's intelligence. If we can measure AI intelligence with that kind of precision, how should that change the way we think about the things we can't easily measure? Things like human judgment, empathy, irreplaceable context, the very things judges and doctors argue must stay firmly in the human domain. Does measuring the measurable make the unmeasurable even more important?
That's a great question to ponder. Thanks for diving in with us.
We'll catch you on the next deep dive.